Hi math friends, let's check out our proportions review together so you can see how you did on this, see what additional support you need, and check it by yourself. So first we're trying to find out if these relations are proportional. And here remember we're going to do y divided by x, the y value divided by x. And if it's consistent, it'll be proportional. So for this first one, we're looking at 222 divided by 18. Just realized it's not what I wanted it to be there. So we'll lower the size of that. So 222 divided by 18, and of course we can use our calculator. We should also be showing work for this as we go along. So for that you're going to get 12.3, and it's like 33333 repeating. And then we're going to divide the other ones. 192 divided by 30. And that's going to end up equaling 6 4/10, or 6.4. So these ratios are not the same, so we're going to say not proportional. The ratios are not consistent, or not equal. So that's what we're looking to do for each of these. Checking out 3 and 4, same idea. So we're going to do 20 divided by 16, and we get 1.25. Then we also get 15 divided by 12. We also get 1.25. So this one is proportional. So we can say proportional, and we're going to say the ratios are equivalent. And we could also add the constant ratio is 1.25. If you want it as a fraction too, you could say 5/4. Leaving it as a decimal is okay as well here. Let's check out this next one. So we're going to do 32 divided by 27. And it's going to be 1.185, rounding a little bit here. Next one, 19 divided by 12. It's 1.583. So trying to trick us here, right? Some of the digits are the same, but it's not exactly the same. So we're going to say not proportional. And you can say the ratios are not equivalent. Okay, let's check out 5. So same idea, just more practice on this so that we can really practice this well like we've been doing in class. So divide these and we get 1.8, and then we get 297 divided by 165, and we also get 1.8. So we could say this is proportional, and say the ratios are consistent with a value of 1.8. Number 6, so same idea, 192 divided by 48. And we should notice something here, right? Both of these, the totals are 192. So it shouldn't be the same number. I'm still going to show my work to show that I know how to do this. So yeah, if we divide it by the same second, so this is 3.555555, so we can round it a little bit there. We can end with a 6, and we're going to say not proportional. You can say the ratios are not equivalent. Alright, so yeah, like 192, if we divide it by a different number, it shouldn't be the same answer. Alright, this one with a graph. So for a graph to be proportional, it's got to be linear, just like number 7 here, and it has to go through 0, 0. Looking at number 8, it is linear, it's straight, but it's above the origin. It doesn't go through the origin. So we're going to say not proportional. We could say it's linear, but it doesn't pass through the origin. And I'm going to remind you here that the origin is 0, 0. Always good to have that on there as well as we need to. Alright, now making proportions and solving. So we have to be careful with how we write these, right? Number 2, the things that we're comparing here, 18 wind turbines. And I'm going to abbreviate wind turbines as WT here, just so I have room. They power 6 houses. So when I write my proportion here, I'm going to keep that And the other part of the proportion that they give us is they say, well, how much for 26 hours? Or 26 houses. So we don't know the number of turbines, so I'm going to write X for that. And then we can do our proportional work. Then we can multiply. You can say 26 times 18. So we get 468. And then we get 6 times x is 6x. And I'm going to draw that on here just so we remember. You know, multiply 6 times x, you get 6x. Okay? So then we need to divide by 6 on both sides. Because remember, 6 times x, the opposite is dividing by 6. So I'm left with x. The other side, when we divide by 6, we're left with 78. So then the question is, how many wind turbines are needed to meet the electrical needs of 26 houses? So we can say we will need 78 wind turbines. All right, make sure that we have those labeled because, and we have a sentence at the end is our answer here. All right, number 3, so same idea, but read this carefully. This is comparing 32 people every 4 hours. So that's going to be in our first ratio. In our second ratio, we want to keep people in the numerator and hours in the denominator. So they tell us, how about for 63 hours? How many people? Well, we don't know, so x. All right, and then let's multiply. 63 times 32, we're going to get 2016. And then we're going to say 4 times x. Well, that's 4x. All right, so then we got to solve that, right? So divide both sides by 4, because that's where the variable is, where the x is. So we should get, if we divide properly here, 504. All right, and then we're going to make sure that we write a sentence. We're going to say the population would be 504 people. All right, next one, kind of tricky the way it's worded too. 4 out of every 10 people. So it says 4 out of every 10 people have downloaded music. So we're going to say 4 people. So these are the amount of people that have downloaded music out of every 10. So like 10 is your total. All right, so whenever we see that ratio given to us as something out of something, that's the total. I'm going to underline that right here. That's how we get that. All right, and it says at this rate, out of 60 people. So think of that, out of 60. So that would be our new total. So 60 is going to be your total over here for this ratio, right? And we don't know this value yet, so I'm going to put x people, and then we're going to go ahead and multiply. 60 times 40, we get 240. And then 10 times x is 10x. And I'm going to draw the arrow here so we remember 10 times x this way. All right, remember, check this as you're going along, because if you try to look at the end result, you're going to get really confused. Because it doesn't look like it does as you're going along, right? Divide by 10 here, we get x equals 24. All right, and going back to our question then, when that 24 people have downloaded music. So we're going to say 24 people downloaded music. All right, a few more proportions like this. It says a string on a piano vibrates 87 times in 3 seconds. So we're going to say 87 vibrations for 3 seconds. And then it says how many times does this string vibrate in 12 seconds. So if we know that it's 12 seconds, we don't know the number of vibrations. So x, I'm going to abbreviate this here. Remember, we always keep that seconds is in the denominator, so we keep it in the denominator both times. That's going to help us keep everything in order. So we multiply 12 times 87, and we get 1,044. 3 times x, we get 3x. All right, multiply that way and multiply that way. When we divide by 3 here, we should be able to get our answer. We get 348. So then our question was, how many times does this string vibrate in 12 seconds? We could say the string vibrates 348 times in 12 seconds. Really quite amazing, and that's how music works. All right, number 6, we're looking at a 10-ounce package of cookies costs $2. So 10 ounces, I'm going to use the abbreviation OZ, costs $2. And it's saying assuming that it has the same cost per ounce. So how about a 35 ounce? Usually it costs less as you increase, like less per ounce, but we're assuming for this one that it's going to be the same cost per ounce. So we don't know the amount of money here. I'm going to put X dollars, and then we'll go ahead and multiply. 2 times 35 is 70. X times 10 is 10x. All right, and go ahead and divide, and look, our x is over here, so divide by 10, and I get 7 is my answer. Okay, so what is it then? It says, what does a 35-ounce package cost? We're going to say this would cost $7. That 7 is the cost there. There, we'll write it like that. All right, a couple more proportions for practice here. It says on Mercury, you weigh 2 pounds for every 5 pounds on Earth. All right, so on Mercury, you weigh 2 pounds. I'm going to put an M for Mercury for every 5 pounds on Earth. All right, if I can think of my proportion like that for different weights on different planets because of the gravitational pulls, that'll help me. And labeling the M and the E is really going to help here. Because look what happens over here. It says you weigh 135 pounds on Earth. So that tells me I should put that in the denominator here. Because I want it to be straight across from the pounds on Earth. And it says how much do you weigh on Mercury? So we don't know that. X pounds on Mercury. Alright, so now we can multiply, and we can, remember when we do the equations, we disregard the labels until we get to the end now, because we already set it up right. So we can disregard the pounds and everything. 5 times x is 5x, and then we divide by 5, and we should get 54 is x. So we can say you would weigh 54 pounds on Mercury. Alright, our last one says after walking for 15 minutes, the treadmill says 120 calories burned. So 15 minutes, 120 calories is what this person burned. Alright, so good little workout for them. And let's see what happens in 65 minutes. So 65 minutes, remember this, the reason that I write the minutes up there is it helps me say, oh yeah, I should put minutes up there again in the numerator. And we don't know how many calories they burned yet, so we're going to work it out. Alright, let's go ahead and multiply x times 15, that's 15x. And multiply 120 times 65, we get 7,800. So if we divide by 15, we end up with x equals 520. And I'm going to look back that 520 referred to calories, so we could say Zachary burned 520 calories. Alright, our next part here, we got some graphs. So this is really practice with plotting the graph. So our first point here, 14, 12. So remember that when you write that, you write 14, comma 12. So we're going to plot that. So over 14 and up 12. None of these are too difficult to plot here. 35, 30. And if you look at these grid lines really carefully, they're going up by 7. So 35 is here. And then this scale is going up by 6. So this is 30. All right. And these are, they tell us that these are proportional. So it should be a straight line at the end. 49, 42. It is important that we plot all of these because that's part of the skill that we're looking at is, can I plot these properly? 70, 60, so 70 and then up 60. And then remember, after we do that, we want to make our line through, and it should go through the points nice and straight, and it should be proportional, meaning it goes through 0, 0, and it's linear. Right? Now, if we want to find that, that ratio, we're going to do jump shots over free throws, or y over x. And for this one, it's 12 over 14. I would always use the lowest one. Two things you could do here. You could say that's equal to 6 over 7. If you want a decimal approximation, you could always divide them, and we could also get that as a decimal. So either way is okay for us. I'm going to write the word or here. All right. The important thing is that we can plot them, and that we can know that it is proportional. So this 6 over 7 lasts for the entire plot here. All right. Same with the other two that we have to plot. Number of blue beads used and number of red beads used. So 28, 12 over 28 up 12. 42, 18. So 42, then 18. 56 and 24. And then 63 and 27. And we're going to make our line through those nice and straight. So use a ruler, use the edge of a notebook. Anything you got, an index card is great for this. Whatever you got to make that line nice and straight, because that's a really important part here. All right, so if we're writing a ratio here, R over B is 12 over 28. That's going to end up simplifying to 3 over 7. If you want it as a decimal, do 3 divided by 7, top to bottom. Yeah, remember top to bottom when we divide. Numerator divided by denominator. It's not big number divided by small number. All right, this ratio is going to be important for us. We could approximate as a decimal if we want to, so either way is fine here. All right, and I put the wrong thing there, sorry about that. All right, last one we got to plot 210, so 210 is right here. 630, so over 6 up 30. 735 and 9 and 45. And remember, with these, they are proportional. So when you plot it, if it's not nice and straight through all the points and it doesn't go through 0, 0, you did something wrong. All right, so that tells you right away that you did something wrong. So really good check for us. I did not mean to make that one. I didn't read that. All right. And then for this one, we got our weight in grams over the number of nickels that we have. So we get 10 over 2, and you could write 5 over 1, or you could write 5. All right, let's check out our next one where we have to complete tables. They give us this 250 and 5, so we can use those for our speed. So we can actually do 250 divided by 5 to help us complete the table. Remember, that's going to end up being our unit rate. So unit rate is always per 1. So that leads us to have this 50. Then we can use that for everything else, right? Because I can take 50 and do 50 times 2 to get here. 50 times 0. I like that one. That's easy. Over here, I can do 50 times 4. And I can get 200. And then at the end here, I could do 50 times 30. And I could get 1,500. All right, and it says, what is the unit rate? So the unit rate is where we have the per 1. So the unit rate here is going to be 50 miles per hour. And how far would you travel in 3 hours? Well, 3 times 50, that's 150. So this part is really important because we can get points that are not on our table or not on our graph because we know the unit rate. All right, one more to practice this, assigning tough problems all the time. And we get this one, 36 over 18. So if I divide these, I can get the unit rate of 2. So unit rate is going to be the per 1, so right there. All right, then I can take this 2 and multiply it by everything else. That kind of looked like a plus. Sorry about that. So 2 times 0.5, I'm going to end up with 1. That makes sense. Half a minute would be 1. 0, that's easy. Anything times 0 is 0. And let's use our unit right here. 2 times 5. We got 10 to complete the table. It says complete the table or else. Oh my gosh, I wonder what's going to happen. Last one here, 2 times 21. We're going to get 42. All right, so what is the unit rate? The unit rate we got was 2. And then look at the labels here. It says tough problems. We're going to say 2 tough problems. We're going to write per. And what's it being compared to? Minutes. So 2 tough problems per minute is how we'll write that. How many tough problems did he assign in 60 minutes? Well, 60 minutes times our rate, 2. That would be 120 tough problems. Wow, that's a lot of tough problems. And how mean is he really? The meanest, obviously. All right, so hopefully this helps. Let me know if you guys have any questions, comments, points of concern, and good luck with all that.